Alright guys, we're going to do vodcast 11.2. We're going to talk about the pH scale, and this should be very familiar to you from elementary and middle school, but essentially this is the math part of acids and bases. So let's jump right in. First off, this is what the pH scale looks like. If you remember from your middle school classes, that the pH scale essentially goes from 0, okay, down here, to 14. Now technically that's not actually true. It can go below 0 and above 14, but in general, for most things, that's the way it's going to work. And then there are these specific regions of the periodic table, of the pH scale. So anything that's at 7, exactly 7, we would say that that is neutral. Nice to see, like, the first thing that I write. I've already managed to make it crazy. So anything with a pH of 7 is neutral. So like pure distilled water with nothing else in it should have a pH of 7. That's not necessarily true for tap water because there's usually some stuff dissolved in it. But water should always be right around 7 pH, which would be neutral. In other words, it's neither acid nor base. Everything below 7 is an acid. Okay, so from here down, everything is acids. Everything above 7 are bases. And we talked about what acids and bases were last time. But basically, acids produce hydrogen, okay, hydrogen ions, and bases are going to produce hydroxide, right? So everything up here, generally speaking, produces hydroxides. Everything down here, generally speaking, produces hydrogen ions. You see a lot of really common stuff on here. You'll notice that like all the citrus juices and stuff are all down here on the acid end of the scale. And then there's a lot of sort of cleaning solution type stuff up here at the other end of the scale. But everything above 7 base, everything below 7 is an acid. Now remember that because you're going to be asked, one of the easiest questions on the EOC for chemistry is like you'll have to calculate a pH and then tell whether it's an acid or a base. As long as you do the calculation, pretty easy to tell acid from base. Below 7 acid, above 7 base. So how do we actually figure out what the pH of something is? Okay, because very often it's not actually given to us. We have to go figure out what the pH is. So this is the technical definition of it. The pH of a solution is defined as the negative of the common logarithm of the hydronium ion. That sounds awful, doesn't it? I mean, like that sounds like the worst science definition you've ever heard. Essentially, it's this formula. Okay, pH is equal to the negative log of H3O plus. Remember, H3O plus is hydronium ion. We could easily replace that in the formula with an H plus. In fact, that's the way that I typically write it, is this way. I think that that's just a little bit simpler. But either of these things, they mean the exact same thing. And how you're going to be able to do these calculations, whenever you see anything in brackets, okay, brackets, okay, of any kind mean molarity. Okay, remember that molarity is moles per liter. We did that in the last section. So you may have to calculate it. Most of the time, probably not. It's probably going to be given to you in the problem. But you could calculate molarity and then plug it in to be able to find pH. Okay, so relatively simple formula. Let's actually work one just to see how it works. What is the pH of a 0.025 molar solution of nitric acid? Okay, so here's what we know. We know that my H plus concentration is 0.025 molar. Now you're like, how do I know that? Actually, what I know is that this concentration is 0.025. How does that equate to the H plus concentration? Well, it works kind of like this. If you didn't ask that question, then don't worry about it. Just say, okay, I'm going to read this into my H plus. But it works like this. I mean, nitric acid is going to break up into hydrogen ion plus nitrate ion. And so for every 1 molecule of nitric acid, I get 1 molecule of H plus. So that means that that's the same concentration. Okay, so 0.025 is my H plus concentration. And I mean, really, my formula is pretty simple. I only need one thing to be able to calculate this, negative log of H plus. I know what my H plus is, so I'm just going to plug it in. It is the negative log of 0.025. Now, what you may be saying to yourself, though, is, okay, how do I work that on the calculator? So if you look at your calculators, okay, right here on your calculator is the log key. Okay, so you very simply punch into the calculator, you hit negative log. Don't hit the minus sign, hit the little negative that's, I should have taken a bigger picture, but there's a little negative key down here. Hit the negative key, the log, and then 0.025, and just hit enter. And when you hit enter on that on your calculator, you're going to come out with 1.6. So that means that the pH is 1.6. Now, where would that go? Okay, look on the pH scale, pretty low, that's pretty acidic. The further down you go, the more acidic you are. Just like on this end, the further up you go, the more basic you would be, or the more alkaline you would be, we would say. Okay? So, I know what you're thinking is like, does it get any harder than this? Not really, or at least not by much. I mean, we'll work another one that works backwards, but it's not really that terribly difficult. So, to work it backwards, how does it work? What is the H plus concentration of a solution with a pH of 3.5? In other words, we have the pH first, but we don't, and we're looking for the H plus concentration. Now, there's a couple of ways that you can do that. You could plug it into this formula, and you can copy this formula down, or it might already be in your notes. The other way would be you could just plug it into the regular pH formula. These two things are the same thing. The only difference between them is that I've already done the algebra to get to here. Okay, so this is this formula just reworked to solve only for H plus. So you could easily plug in your pH here, and then if you had, certainly if you've had algebra 2, you could work the logarithms to solve that. But if you're not real comfortable with logarithms, which most of you all probably aren't, then just take it and plug it in. So that means my H plus concentration is equal to 10 to the negative 3.5. Okay, how do you punch that in your calculator? Just hit the 10x key, okay, which is, you may note, if we go back real quick, probably should have put this on the other slide, but if we go back to the calculator that we had in the last slide, you'll notice that on that same key that log is, it's 10x, okay? So basically you just hit second log, okay, which we call the anti-log, and then put in negative 3.5. You punch that in, and you hit enter, and you're going to get out a number that looks like this. It says 316. I wouldn't worry too much about sig figs on this particular stuff, but if you did, that's what it would come out to be. And remember, if you needed units, it's molarity. Anytime you have brackets, it's always going to come out to be molarity. Okay? So that's all there is to those calculations, really. Real quick, we can also get POH. P is like a mathematical term. It always means negative log of whatever you put after it. Okay? That's what we call an operator. So I would find POH the same way I would do pH, except that instead of the concentration of hydrogen, it's now the concentration of hydroxide. So if I had this equation that said, what's the POH of a 0.2 molar solution of sodium hydroxide, it would have to be a base for you to be able to do. Well, it doesn't have to be a base, but it makes it a little bit easier. Okay, so what is my OH minus concentration? Okay, it is 0.2. So my POH is equal to the negative log of 0.2. And we punch that in our calculators, and we get 0.698. Now, there's a little bit of a problem there because we don't ever like talk about a POH scale. We talk about the pH scale. So for this number to really mean anything, I kind of need to turn it into pH. So how do I do that? Well, this is how we take that number and turn it into pH. The pH plus the POH are always going to equal 14, and that's why when we look at that scale at the beginning, it goes from 0 to 14, and this is the reason why, because if we add our POH to our pH, we're going to get 14. So I'm going to take my numbers from that last problem. I had a POH of 0.698. And so to figure out the pH, it's pretty simple. The pH is just going to be 14 minus 0.698. Okay, which means that my pH is going to be 13.3. There's no units on pH, it's just a number, so 13.3. We go back to the beginning and look at our pH scale here. 13.3, way up there. That is a very basic solution. Okay? So, whoops. Last type of question that you are likely to see EOC-wise or test-wise would be something like this. A solution has an OH minus concentration, okay, a molarity of 1.4 times 10 to the negative fifth, is the solution an acid or a base? Okay, so to find out whether it's an acid or base, we need to find pH. If the pH is below 7, it's an acid. If it's above 7, it's a base. So that's pretty simple. So all we really have to do then is figure out what the pH is. Well, since I have my OH minus concentration, I'm going to use POH first, and then we'll do the next step. Okay, don't let the fact that this number is in scientific notation scare you. It's going to work the exact same way. Okay, so POH is equal to negative log of this number, 1.4 times 10 to the negative fifth. So just punch that in the calculator. Make sure you get that negative in there or it's not going to come out right. When we punch that in, we get a POH of 4.85. Okay? And then remember that to find pH, that the pH is actually equal 14 minus the POH. And since we just found our POH right here, okay, that means that it's 14 minus 4.85. Okay? And that's going to give us a value of 9.15. So is that an acid or a base? Well, it's above 7, so it has to be a base. All right? Hopefully everyone figured out how to do those problems. We're going to work, obviously, as always, work some of these for practice in class, and I hope that that goes pretty well. These are relatively simple, so hopefully we can get those done.